continually. Making sense? You're already better media consumers already. If you don't have a margin of error, turn your nose up at it. Seriously. Just demand the margin. Okay, so now you've got your data. You've got your good data. How are you going to share it with the world? Now, there's going to be a bunch of graphics on here. Again, you're going to have this PowerPoint within an hour. I'm going to have this posted for you on my schedule page, not in Blackboard. Blackboard is going to be a wasteland of nothing except for submissions of my assignments. Everything's going to be on that schedule page, right? It's going to keep building as we go day to day. So just so you know, that's where this is going to be. Suppose this is our data. Statistician. This is the numbers it collects. How many products each produces in 1 week? Totally fictitious data. We'll get to more realistic data later. I don't want to hit you with realism and nuts and bolts at first. Let's practice kind of artificially and then build it into more realism. How should we present our data to the world? If we were the employer, how would we want these numbers given to us? In this form right here? Just so you know, there's no correct answer for the question I'm asking you right now. Could the statistician hand them this? Of course. That's what I call raw data. Raw data. I like that. You see every data point, so there's no uncertainty about how many I got. I got 20. There they all are. All right, I know that that's a 17. That's a 30. Right. But Faith is going, no, I don't want to see it this way because
I can't analyze it. I can't do anything with it.
I can't analyze it. It's not clean. I like both of those critiques of it. Right. What would you like to see? A graph, maybe grouped. Maybe what else? A scatter plot. Oh, if it was bivariate, I'd love to do that. Oh, can we wait up? Just a little bit. If there was a second set of data that could correlate with it, like week 1, week 2, that'd be kind of fun. But with univariate data, I like the idea of sorting. Let's think. Here's one thing you can do with it. Here's your raw data. Here, per Faith and Aaron's requests, is order it. Make it more organized. So what this is called is a distribution. Now, make sure you can tell what you're looking at first. Number of products column. Frequency column. Yeah, you can call it a T-chart. It's shaped like a T-chart from Math 60, say Math 65, maybe even high school. Hey, whatever. XY table. Statistics is called an XF table because they call these frequencies. But yeah, T-chart, I like that. We'll call it a T-distribution. Oh, I shouldn't call it that because there actually is a T-distribution. T-chart, we'll call it. So this is your independent variable, if you will, the number of products. Your dependent variable being how many of them. So see if you can understand what the numbers mean. Number of products, 10 to 12. Frequency 1. Why is the frequency of that 1?
Because there's only one between 10 and 12.
Randall, when you look at the raw data, there's only one of those numbers that's a 10 or an 11 or a 12. It's that one right there. Skip down to this one, 16 to 18. I see 5 over there. What does that mean? There are 5 16s or 17s or 18s. Let's find them, assuming Excel did this right. 1, 2, 3, 4, 5. So what you're doing is you're counting how many of the data points are in the left part of the chart. There were none from 22 to 24. There was 1 from 25 to 27. It's also doing an inclusive 25 to 27. It's including 25 and 27, not just breaking them off. 1 from 37 to 39. Cool so far? So, is it organized? More than the raw data? Yeah. Is it ordered? Is it neater? What do you lose? Because remember, you're not going to have this and this in general. You're going to have either one or the other.
You don't know.
Yeah, you don't know.
Good. You lose a little bit of precision, don't you? You know that there are 5 numbers between 16 and 18, but you're supposed to know how many of 16, how many of 17, how many of 18. Was there a 16 and a half in there? Now, we know that because we have this, but suppose you don't have that. It's on my butt, isn't it? Lower back. I got a long butt. We have a tool to deal with this, and I promise not to push it to 244. We'll deal with it on Monday. But that is one of the downsides of a T-table or a distribution, is that you lose a little bit of precision of the data, but you do pick up usability and a little more organization and easier to deal with numerically. Fair? Fair so far? Okay, so that's just called a distribution, or frequency distribution. Frequency being how often things occur. Now, Aaron, you asked for something else, though. He didn't just ask for orderly, he asked for visual. Because this is still one-dimensional. We can make it two-dimensional by drawing a graph of the day. Now this is a tool we're going to use a lot in this class. It's called a histogram. Excel calls it a bar chart. I don't care what you call it, as long as you know what it is. And we're going to learn how to make them in this class. By hand, using the TIs, we'll go use them in Excel, we'll learn how to make these things. You guys in 105 already did learn how to make them in Excel. That's probably your least favorite project. I apologize for that. It was the best.
It was the best.
No. So on average, it was neutral because sucked, great. Average, neutral. Boom! That was 2, n equals 2. See if you can see what you're looking at. It's like John Madden. Can you see what you're seeing? You're seeing the exact same data that you had in the distribution, but now it's two-dimensional. You've got an X and an F. So rather than having it all just flat in a T-chart, you get a beautiful histogram that tells you the exact same thing. So whatever limitations you had in the distribution, you're going to have here too. But you do pick up something fun with the histogram that you didn't have with the distribution, don't you? What do you pick up? What do you gain here that might be missing here? A visual. Why is the visual good? I love that answer. Why is the visual good? Because it's easy to compare. Tell me, David, tell me more. I love this. What are you comparing? When you're comparing?
The frequencies, or you can see the difference in the heights.
Yes.
Clearly those...
He's got my vote. That's my vote. 5 is 5 times bigger than 1. It's hard when you're looking at a one-dimensional number to realize that that is 5 times bigger. That can get lost if you're working quickly through a set of numbers without analyzing them. With the visual, you're like, holy crap, there's a big hump right here. And then there's a secondary hump and then a tail. That might all get lost in the table unless you have the visual in front of you. Isn't that kind of cool? More on that on Monday and what we should learn to look for in a graph like that. But that's really what you get away when you have these histograms, is you're like, oh, okay. I see almost a bell shape with a longer right tail than left tail. You might not have seen that by just looking at this. It's pretty slick, huh? It's pretty slick. That's why I like the idea of a bar chart, a Pareto, or a histogram, because they're very, very nice in that respect. We'll talk more about that Pareto I just mentioned momentarily. Good so far. Ask me questions. I love the vote for visual. We like it because it's more visual. Yeah, human beings are pretty visual creatures. These things are all over. I just got, somebody showed me Time Magazine, the Answers issue. Have you seen that one? None of you guys read Time Magazine. I don't, but I get issues randomly. The Answers issue is full of graphs like this. And it's just like, what's the most dangerous intersection in America? You know, exactly. I don't know what that is yet because I haven't gotten that far yet. I have a 7-year-old, so I read very slowly. Just like a page at a time, half page at a time. But it's full of graphs and graphical depictions. I want to have you guys critique 1 or 2 of them on quizzes coming down the pike. Because I'm not sure if some of them are done properly. I'm going to have you guys decide. Now, this idea of histograms. I want to stick with that. Oh, Aaron, no.
Are you still losing some of the precision?
Yes. As I said, whatever you lost here, you're still losing here. But you do pick up that visual element. Not that it replaces what you lost. Very good point. Very good point. You don't pick up what you lost, but at least you get something else that's mathematical and actually quantifiable.
5 times.
Yes, 5 times as big is visually set where it's only numerically set there. Yeah, but Aaron's point is well taken. We still don't know how many of these 5 are 16 or 17 or 18. Just that they're between those two. Very, very true. I want to keep, for the remainder of today, except the very end, which I want to share some really fun stuff that I've discovered over